Okay, so a lot of you have been asking about question number 4 on page 410, and I've kind of set the question up so that you can see, first of all, a top view of the two wires that are showing currents going in opposite directions. So again, let me just write this down. I have, first of all, a top view, and if you take a look at these two wires, let's take a look first of all at this guy over here. I have a current of 10 amps going going up in this top view, and I also have a current of 20 amps going down this way. First of all, you can see they're going in opposite directions. Now, if you take a look at the 10 amp current over here, if you were to wrap your right hand around this wire, you would notice that your fingers curl around this wire so that the magnetic field around it goes in a direction that looks something like this. On the right side of it, you have a magnetic field going into the page, and to the left of it you have a magnetic field coming out towards you. So what you basically have is, if you can imagine this in 3 dimensions, you have a magnetic field going this way, and then around the other side, around the front side, and so on and so forth. So kind of like we did in class, that's what these X's and dots represent. Now, let's take a look over here at the 20 amp current going down. If you were to wrap your right hand around this wire, what you would now find is that to the left of it, you have magnetic field lines going into the page, and on the right side of it, you have magnetic field lines going out towards you. Okay, so what this question is saying is this. If you take a look at the midpoint, and again, let me just draw this midpoint as this dotted line over here. If you take a look at the midpoint between these two wires, what they're really saying is, what is the net magnetic field at this midpoint that's been created by, first of all, the 10 amp current, and then secondly, the one created by the 20 amp current. So how would you go about solving this? Well, just for simplicity, let me call this wire on the left A, and I'll call this wire over here B. Let me just reduce this a little bit. And let's look over here on the right hand side. So the first thing I want to do is I want to see if I can figure out what the magnetic field at that midpoint is as a result of wire A. And we also know that this is actually going to be equal to the permeability of free space times the current in wire A, all of this divided by 2 pi r. So if you take a look, we know that mu is going to be equal to 4 pi times 10 to the power of negative 7. The current in this wire is 10 amps divided by 2 pi. And the distance at the midpoint, so the distance at this point away from wire A happens to be, well, not 1 meter, but 0.5 meters. So let me just write this down as 0.5 meters. And what this does is it gives you some kind of an answer. And again, if you solve for this, you'll notice that whatever answer you get, the direction of this magnetic field at the midpoint is, of course, into the page. Okay, and that's how you would solve this first part. Now, is that the only magnetic field that exists? No, it's not. By the way, just to let you guys know, I haven't filled in the answer over here because I'm going to let you guys do that at home. But if you do take a look at wire B, we can also do the same thing. If I take a look at wire B, I know that there's a magnetic field at the midpoint as a result of wire B as well. So this will also be equal to the same thing, mu naught I divided by 2 pi r. Okay. Now, what I'm going to do is, let me see if I can just scroll up this way. Just ignore these diagrams down here. In fact, let me just see if I can get rid of them right now. If you take a look at wire B, we also have the exact same thing. So we got 4 pi times, oh, what did I do there? I don't even know what I did there. Let me erase that. So let's try that again. 4 pi times 10 to the power of negative 7. Now, if you take a look at wire B, its current is 20 amps. That's all this divided by 2 pi. And again, 0.5. Now this will give you another answer, and if you take a look, the direction of this magnetic field is also going into the page. Now the value that you get over here, it's going to be another different value. So what the question is really asking you to find now is, what is the net magnetic field? So to find this magnetic field, all you got to do is take this answer plus this answer And what you're going to do is you're going to take those two values, BA plus BB, and you end up with a numerical value, and all you have to ask yourself is, well, wait a second. Since both of these are going into the page, then the net magnetic field must also be going where? You got it, into the page, and that's all the question's about. Okay, so the question doesn't mention anything about whether these two wires are going to attract or repel. Okay, so this particular question isn't asking about that at all. So just be careful when you read this question, you know what it's really asking for. Okay, anyways, hope that helps you guys. Have a good night. Thank you. And let's